This is Jenny Kunkel, and in this video we're going to start looking at database table design. And we're going to start by looking at what some of the issues are with bad design. To begin with, we're going to recap what we've learned thus far this semester, and this is around a table being two-dimensional, containing rows and columns. We've seen this as we've been using our SQL statements, when we've been using our DML to update, using our insert, update, and delete statements. We know that every table row represents a single entity occurrence within the table. We also know that each table represents an attribute for each column, and that all of our values within a single column have the same type of data that's stored there. And we know that we have been interacting with our Northwinds and our AdventureWorks tables, and they all have primary keys. Now, I know in industry I've seen in some instances where tables do not have primary keys. Generally, these are going to be one-row tables that are used more for configuration data. Although it's not a best practice, I have seen it in action. Now, as we transition into our database design, we have been using the results of physical design. And this is going to be where tables, columns, and rows have already been generated as an output of the physical design. This week, we're going to be spending all of our time looking at the logical design, and this is where we have entities that when it goes through the physical design process will end up as tables. And we have attributes that when we go through the physical design will result in columns. There is a third portion that is on the front end, and that's the theoretical, where we get into relations. That's essentially what an entity or a table will become. And we have the attributes as well in the theoretical as the logical. And then we have tuples, which are essentially the rows. The theoretical is a little bit of out of scope for this class. We're not going to be looking at the theoretical design. We'll be looking at our logical and then moving into physical. This week, we're just going to be focusing on the logical though. In terms of what we have our entities. Those will become our tables, and they are going to represent person, places, things, or events. We also have our attributes, which are going to end up as columns that are going to be a property of the entity. And then with our entities, we're going to have associations between the entities, and those will result as our relationships that are going to be implemented as one-to-one, one-to-many, or many-to-many. And usually when we do a many-to-many, that's going to involve more than two tables. With our one-to-many, we've seen this implemented as foreign key associations. And as we do our physical design, that's how we will implement those types of relationships. Typically, your one-to-one, you do not see a whole lot of those. You see few of the many-to-many. You generally see more of the one-to-many relationships. Now, if we start looking at some of the issues, typically users, when they provide you with some of the information for database design these days, it's going to be in a spreadsheet, because everybody loves spreadsheets. And if we tried to design a table based on a spreadsheet that somebody provides us, it may not result in the best table design. If we look at this particular spreadsheet example, we have a student ID, student name, then we have course 1, instructor 1, course 2, instructor 2, course 3, instructor 3, and that is not very sustainable from a table perspective. What happens if somebody decides later on that they want to add a 4th class or a 5th class or a 6th class? We would have to go ahead and alter the table, add a new course and a new instructor for each one of those. That's not going to be something that we can cleanly query. And how do we go about updating that from a program perspective? If we need to insert data, if we need to update data, if we need to delete data, that's going to be a little bit easier, but the insert, update, and querying is going to be a little bit of a nightmare to actually accomplish. And we want to keep things simple. So those repeating groups, those are something that we need to look out for. Now, in this case, it's very intuitively obvious that we have a repeating group. Sometimes based on the way that the users provide us data, it's not necessarily as easy, and we have to kind of look at the relationships that they've kind of given us with the data, and then see that we have duplicate data within columns in order to understand that we have repeating data situations. The next type of issue that we come up with is we have instances where they provide us all the information for a particular table. And in this case, this is going to be for an order and for the order line. So in this case, we have the order line, we have the supplier information and the product information all in one table. Well, that's okay, but that's not going to be something that we can just create one table and take care of everything, because we should understand that hopefully our table is going to be huge because we're submitting lots of orders, and we're going to have lots of redundant data because we're going to have that supplier name and product name, which are going to be larger fields because they're textual based, and we're going to have a lot of redundant data stored there. And that gets into what happens if we decide that we need to update all of our references for Text Supply Inc. and something goes wrong and we only get one of the rows updated. Well, what's that going to mean? That we have a disconnect between our supplier 5001 data. When we refer to this as an update anomaly, when we have data that is not the same throughout the table. We've updated the data and something's gone wrong. We have some information that's showing one value. We have other information that's showing another value. And so that's not ideal. But then we also have, well, how do we insert new supplier information or product information if we don't have an order? So it's going to be a little problematic there. We can't maintain some of that base information unless we have that order, or we have that product, or we have the supplier. We need all three of those types of information in order to be able to store something in the table. Because if we're keying this by a primary key, chances are we're not going to have the whole entire primary key in order to store the information. We also get into an issue if we were going to delete order 1002 based on the information that we see, we would lose all of the product and supplier information. So we have no data that would be stored for Office Goods Limited at that point or for the printer, because we have no other references in the table for that information. So those are considered to be insert and delete anomalies. And one of the things that we need to be able to handle with our data is we need to be able to compensate and not have anomaly type situations when we design our table, and make sure that everything that gets stored is good and well, because if we start having garbage in our tables, then our data is not going to be consistent. We're not going to be able to count on our data. And it's always something that we really want to be able to do, is ensure the quality of the data, because without quality data, we don't really have a good system that we're developing. And that's essentially all the material that we're covering in this video. In the next video, we're going to dive into some of the design rules of how we actually go about trying to make sure that we don't run into these particular scenarios with the repeating groups. How do we avoid those? How do we avoid some of the conditions where we have dependencies on data within our tables? So we'll look at some of the rules that we use to resolve those and go through some examples.